Hey, Course 3. Today we're solving proportions, which is one of my favorite things because they make a lot of sense, they're fun to do, they have a simple process you get to follow that's easy to remember. It involves ratios, which, as you remember, they look like fractions. We've got a quantity on top compared to a quantity on the bottom. We can use a certain process to consider whether two values are proportional, we call it. Are these two quantities truly proportional, meaning do the fractions equal each other? Are they proportional? Do they form a proportion? Do they have the same relationship top to bottom? Basically, what a proportion means is, do each fraction in the end reduce to the same thing, which in this case is obvious. I could reduce that down to 1/2 pretty quick, but sometimes it's not so obvious, like here. I can't always just look at something or even divide it quickly and find this very simply, nor can I use this later for word problems and missing values. But a certain process is true that if you multiply these, you get, just to show you, that's I think 72, right? 12, 2 times 6 is 6 plus, 2 times 3 is 6 plus 1 is 7. And if I do that with this one, right, 3 times 2 is 60, 6 times 2 is 12, plus that together, you got 72. So 24 times 3, we could show like that, is the same as 2 times 36, or 36 times 2, right, commutative. The cross products from this proportion are indeed equal. Therefore, it's in proportion. That's a way you can check, by cross multiplying and setting those values equal to each other. They should be equal. We can use this then when solving a word problem like Nelson has a paper route. If he works by himself, the job takes 60 minutes, and if he splits the route with a friend, it takes 30 minutes. If two friends help, the job takes 20 minutes. Is the amount of time it takes to complete the route proportional to the number of people working? Okay, so is 60 minutes for one person proportional to 30 minutes with two? And then we've got 20 minutes for him and two friends, which is 3 people. Are all these proportional? This looks pretty good, I can already tell, but actually, for a second I think, yeah, pretty simple, but you multiply this across, 120 is not 30, is it? And 30 times 3, which is 90, does not equal 40. So these are not proportional, the way I'm understanding it. We can use it also when we're missing a value. The ratio of boys to girls, so boys on top, girls on the bottom, in the class is 3 to 4. Okay? Boys over girls is 3 to 4. Sometimes it's good to show this part so you have the top and bottom right. If there are 12 girls, we're trying to form a proportion here, how many boys? So this is the unknown. Let's just keep the variable b. So you solve these by cross multiplying. 12 times 3 is 4 times b. You don't need a parentheses because the letter looks different. Then you multiply that. 36 is 4 times b. Now we just divide. We divide this by 4. We divide this by 4. 36 divided by 4 is 9, is b. That's how I solve those. Okay? You could also, if you really struggle with this process of cross multiply, set equal, and divide, you can simply go 4 times what is 12, therefore 3 times that is b. 4 times what? 4 times 3. 3 times 3 is what? Is 9. Okay? How can I check? 9 times 4, 3 times 12, everything is 36. Therefore, 9 is indeed the answer. Okay, so you can solve that either way. The old way or the future way you're going to need for algebra. That's why I teach it to you now. if it asks you to make a ratio table, it looks like this, where you put boys over girls like I did here, and then you write ratio and actual count. The ratio is 3 to 4. Well, the actual is b to 12. Therefore, we have basically the proportion set up. Okay? Why don't you try one from each of these? So do either A or B. C through H, pick one, and do I or J.